teach you about square root. Square root is something of a complex mathematical process, rather than the basics. Addition, subtraction, multiplication, division and exponentiation. The mathematicians have discovered a few logical methods to find the square root of a real number. Today I'm gonna explain the reason for the globally reputed standard method of solving square root, the dividing method. Come and enjoy art science, which touches the artistic places of science and makes people informed. Most of integers have no exact integral square root, and also we can't find a finite number of decimal figures for their square roots. So we want to do an approximation and an estimation. If we want to find the square root until nth decimal figure, we have to find it until the 1 plus nth and estimate. As an example, until 8th decimal figure, the square root of 2 is 1.4142136. If we want it until 7th, we can take 1.4142136, because 6 is greater than 5. That is estimation. The most primary way to find square root is simple approximation, that we have to find between which couple of perfect squares the number we want to extract its square root lies. Then the square root of the particular number lies certainly between the exact square roots of those two perfect squares. Then we have to choose which perfect square is closer to the number. If the smaller one is closer, the first decimal figure of the square root will be less than 5. If the larger one is closer, it is greater than 5. Then we could write down the squares of the decimals between two exact square roots and find which one is the closest to our number. Its square root is the estimated value we want. We can find first approximation, second approximation and third approximation and so on as we wish. But this is a very hard toil, so we can use the dividing method to find square root quite easily. First I show you how we can extract square root of a number using this method, and then I hope to explain its mechanism stepwise. Choose any number you like. I choose 131,034. First, separate the digits of the number into periods of 2 from the right corner. We can find 3 groups in this number. If the number consists of an odd number of digits, the last period in left side corner will contain only 1 digit. Don't mind it. Then find the less and closest perfect square to 13, which is the first period from left. It's 9. If the first period is a perfect square, it should be chosen itself. Put the square root of 9 at these two places. It's 3. Then subtract 9 from 13 and it's 4. After that, take this 10, the next period, down to here. Now, consider these 3 digits as an entire number. It's 410. Perhaps it can be a 4-digit number, but don't mind. Then multiply this 3 by 2 and place it right here. It's 6. Leave a space here for another digit. Then let's inquire how we can find out the digit. If that digit is 8, 68 times that must be the less and closest product to 410 we can have of this type. This 68 means 60 plus 8. 65 times 5 equals 325, 66 times 6 equals 396, 67 times 7 equals 469. 469 is greater than 410, so it's invalid. 396 and 325 are less than 410, and 396 is closer to it than 325. So 396 is the most suitable product, which comes by 66 times 6. Therefore we can fill this space with 6, so it becomes the second digit of the expected square root. Then subtract 396 from 410 and write it down here. According to the aforesaid order, take the next period 34 down to here, and consider this as a whole number, 1,444. Then again, consider this 3 and 6 as 36 and multiply it by 2, and write it down here, leaving a space sufficient for 1 digit. If that digit is b, again find the product of 720b times b to be less and closest to 1434. Sometimes it can be equal to 1434. Exactly here, 722 times 2 equals to 1434. Then subtract these two numbers and it becomes 0. So our number is a perfect square. If the number we chose was 131,045, there would be a remainder of 1. In this situation, we have to place a decimal point after this 2, and write down the multiplication of 362 into here, and take 2 zeros after 1 in order to the whole number be 100, and then continue the previous process. We can apply this order again and again, adding couples of zeros at the end of the remainder, and extract the square root until any number of decimal figures as we wish. If you've chosen a decimal number, you should separate periods starting from the decimal point through both left and right sides. If it is an odd number of decimal figures, put a 0 after the last one, since it makes no difference of the value of the number. Then let me explain the mechanism of this process step by step. First, we separated the number into periods of 2 digits. Why do we do so? There's a nice numerical pattern in mathematics to recognize. That is, if we take this x, y, z as a whole number, the x, y, z to the power n will have 3 periods of n digits. If it is w, x, y, z, the w, x, y, z to the power n will have 4 periods of n digits when separated, beginning from the right quarter. The number of periods is equal to the number of digits of the root. If it is a decimal number, the digits of the root and the periods of the power ought to be counted through both sides starting from the decimal point. Since the power is 2 here, we should separate the number into periods of 2 digits. The second thing we do is to find the closest perfect square, equal to or less than the first period. Now, for a moment, pay your attention to the extraction of the square root of 196. Here we subtract 1 from 1 and take 96 down. It is another form of representation of subtracting 100 from 196, because this 1 is at hundredths place in the number. So the answer becomes 96. This process is related with binomial expansion. A plus b squared equals a squared plus 2ab plus b squared. In accordance with this very form, 14 squared equals 10 plus 4 squared equals 10 squared plus 2 times 10 times 4 plus 4 squared equals 100 plus 80 plus 16. This 100 is what we subtracted at this step. Then we write down a 1 in the tens place of the square root, because we know that there are 2 digits in the square root, since the number has 2 periods. So this 1 represents a 10. Then we multiply that 1 by 2 and write it down here, leaving a space for a digit. Likewise, this 2 represents a 20. If the digit here is x, 20 plus x times x equals 96, because we get 96 by multiplying these 2 numbers. Then we can solve this quadratic equation, and answer for x becomes 4. Therefore, 196 equals 100 plus 20 times 4 plus 4 squared equals 10 squared plus 2 times 10 times 4 plus 4 squared equals 10 plus 4 squared and equals 14 squared. Hence, the square root of 196 is 14. So this process merely depends on binomial expansion. Then let's inquire how we can extract the square root with more than 2 digits. Observe this expansion. Let's turn back again to our first example of 362. Here 3 is at hundredths place and represents 300. 6 is at tens place and represents 60. 2 is at units place and represents 2. According to the above model, A equals 300, B equals 60, and C equals 2. First we subtract 90,000, which is the square of 300, and as well as A. Then we double this 3 and find x of 69 plus x times x be less than or equal to 410, as 69 plus x times x to be an integer. Here x becomes 6. Because the 6 is a tens place of the square root, it represents 60, so this equation becomes 600 plus 60 times 60 equals 39,600 equals 300 by 2 plus 60 times 60, and it is with related to 2a plus b times b in the above model. Then we have 722 by 2 equals 1434, and this represents 2 times 300 plus 60 plus 2 by 2. This is related to 2 times a plus b plus c by 2 in the above model. We can expand this equation for any number of digits, and use this process to extract square root.
Thank you for watching this video. If you gained something from this video, don't miss to like it and share it. Subscribe my YouTube channel for more video like this. Click the bell icon for getting a notification about my channel. See you again.